All right, buckle up, everybody, because today we are going on a serious mind trip.
Yeah.
We're talking the entire lifespan of the universe,
Wow.
from its crazy beginning to its potential end.
Right.
And believe me, we're dealing with timescales that make human history look like,
Nothing.
yeah, like less than a blink.
It's true.
You've given us some seriously fascinating sources about all of this.
I tried.
Research papers, articles, even some kind of wild theories. I have to say, I was a little intimidated at first.
It is a lot.
It is. It's dense, but that's why we're here today, to unpack it all.
That's right.
So what is the most surprising thing you think we're going to uncover today?
Well, I think it's how much we actually know about the universe's history, from the Big Bang to the
Right.
formation of galaxies and all that.
Yeah.
But also at the same time, the deeper we go, the more we realize just how many mysteries there still are.
Oh, okay. I'm intrigued.
Yeah.
Let's start at the very beginning.
Okay.
The Big Bang.
All right.
Now, I always pictured it kind of like this massive explosion,
Sure.
but our sources paint a slightly different picture.
They do. Yeah. It wasn't really an explosion in the way that we normally think of it.
Okay.
It's more helpful to imagine like a tiny, super hot, dense point,
Okay.
smaller than an atom even,
Wow.
suddenly expanding at like speeds we can't even comprehend, billions of times faster than light.
That's a lot.
And this is called the inflationary period, and it's really important for understanding why the universe looks the way it does today.
Okay, so instead of things being scattered randomly from an explosion, this rapid expansion kind of smoothed things out.
Exactly. Yeah. And that smoothness is one of the biggest clues we have about those very, very early moments. When we look at the sky in every direction, the universe is remarkably smooth at those large scales.
Uh-huh.
And the laws of physics are the same everywhere. And that kind of consistency points to a very, very specific kind of beginning.
So are you saying that everything we see, galaxies, our planet, everything, all originated from that same tiny point?
That is what the Big Bang model says, yes.
It's really hard to wrap your head around that.
It is.
Okay, so what happened next? Did things calm down after this insane expansion?
Not exactly, no.
Okay.
The universe was still unbelievably hot and dense. And actually for about 380,000 years after the Big Bang.
Wow, that's a long time.
Well, on a universal scale, it's not that long.
Okay, true.
It was actually too hot for light to travel freely.
Wow.
It was basically this dark, opaque soup of just like particles.
Huh.
But as it continued to expand and cool, something incredible happened.
What's that?
Atoms started to form.
Okay, so atoms, like the building blocks of, well, everything, are starting to come together.
Yeah.
I feel like this is where things start to get really interesting.
Absolutely.
Yeah.
And when those first atoms formed, they released a flash of light.
Oh, wow.
And this was like a burst of energy that's been traveling through the universe ever since. And today, we can still detect that ancient light.
Really?
Yeah, it's called the cosmic microwave background radiation.
Like a baby picture of the universe.
Exactly, yeah.
Wow. But wait, you said dark age earlier. Didn't things go dark after this first light?
Yeah, that's right. Once the atoms formed, the universe did go dark again.
Huh.
And this time it stayed that way for millions of years.
Okay.
And it's what we call the cosmic dark ages. And this period lasted until the very first stars began to ignite.
Okay.
And then it flooded the universe with light and heat again.
So for millions of years, it was just darkness.
Yeah, pretty much.
And then, boom, the first stars. That's amazing.
Yeah.
What was so special about these early stars, though? Were they like the ones we see today?
Not really, no.
Yeah.
They were absolutely massive, like hundreds of times more massive than our sun.
Really?
And because of that, they lived fast and died young,
Oh.
ending their lives in these spectacular supernova explosions.
So, hold on. Are you saying that the elements that make up, like, everything around us, the carbon in our bodies, the iron in our blood, all that stuff came from those early stars?
Yeah, that's exactly right.
That is incredible.
Every element heavier than hydrogen was created in the heart of those dying stars.
So this gold ring that I'm wearing
Yep.
is literally stardust.
Stardust forged in a supernova billions of years ago.
That is amazing.
Yeah, it's a pretty amazing thought.
I am speechless. We are stardust.
We are.
Okay, what happened next in this cosmic story? Where do galaxies come in?
Well, those early stars, they didn't just create elements, they also started to clump together
Okay,
under the force of gravity.
right.
And they formed the first proto-galaxies.
Proto-galaxies.
Yeah, and these were kind of chaotic, swirling masses of gas and dust and stars constantly colliding and merging.
So these early galaxies were kind of like the messy teenagers of the universe, just kind of figuring things out.
Yeah, I like that analogy.
Yeah.
Over billions of years, though, they matured and evolved into these like majestic spiral and elliptical galaxies we see today.
Oh,
And our own Milky Way is actually one of the oldest galaxies that we've ever observed.
wow.
It's this grand spiral that's been around for almost as long as the universe itself.
The Milky Way, a seasoned veteran of the cosmos.
It is, yeah.
Makes you wonder what it's seen over all those billions of years.
I know, it's amazing to think about.
It is.
And within the Milky Way, there are actually stars that are almost as old as the galaxy itself.
Really?
Yeah, one in particular called HE 15230901.
Okay.
It's like a relic of the early universe. Looking back at it is like witnessing the universe in its infancy.
It's incredible.
It is.
But I have to ask, what's in store for our galaxy? Does this cosmic story have an ending?
I mean, every story has an ending,
Yeah.
even a cosmic one. And the Milky Way's future is, well, it involves a rather dramatic encounter with another galaxy.
Wait, another galaxy? Are we talking like a cosmic collision?
We are.
Oh, wow. This sounds intense.
It is pretty intense.
Okay, well, let's talk about that. What happens when galaxies collide, and what is the ultimate fate of the universe?
Yeah, let's get into it.
Okay, galactic collisions. I have to admit, the idea of galaxies crashing into each other sounds pretty catastrophic.
Yeah, it sounds violent, doesn't it?
It does.
But it's actually less of a head-on crash and more of a
Okay.
slow gravitational tango.
Okay.
And remember, galaxies are mostly empty space, so it's not like stars are actually like smashing into each other left and right.
Okay.
Instead, it's more the overall gravitational forces that really shake things up.
So it's more like a cosmic reshuffling.
Exactly. Yeah.
Okay, so what happens to the stars and planets during this reshuffling?
Well, the gravitational interaction between the two galaxies can send stars and gas clouds like careening off in new directions.
Wow.
Some stars might even get flung out of the galaxy, completely becoming like
Oh,
cosmic wanderers.
imagine being a planet in a solar system that gets ejected from its galaxy.
I know, right?
Talk about a change of scenery. But what about the galaxies themselves? Do they just merge into one big blob?
Over billions of years, yes, they do eventually merge into a single larger galaxy.
Okay.
But the process is anything but boring.
Oh.
Yeah, all those gravitational forces really distort the shape of the galaxies. And they pull out these long streamers of stars and gas. It's pretty messy.
So our beautiful spiral Milky Way is going to get all warped and twisted.
Pretty much, yeah.
I guess beauty is in the eye of the cosmic beholder, right?
That's one way to put it.
But what about our solar system? Where will we end up in all of this?
Well, it's impossible to say for sure. But simulations suggest that our solar system might actually get pushed out to a wider orbit
Okay.
within the merged galaxy, so we might even end up with a whole new view of the night
A
sky.
new night sky. Okay, that's kind of exciting.
Yeah.
But let's zoom out even further. We've talked about the beginning of the universe,
Right.
the evolution of galaxies. But what about the end? What's the ultimate fate of all this cosmic wonder?
That's a question that's fascinated cosmologists forever.
Yeah.
And, there are a few possibilities. One possibility is what's called the Big Crunch.
The big crunch.
And this is where, imagine the universe's expansion just slowing down,
Okay.
stopping, and then reversing.
Oh, wow.
Everything would start to contract, pulling galaxies closer and closer together until everything collapses back into like a single, incredibly dense point.
So kind of like a cosmic rewind.
Yeah.
Pretty
that's
much
it.
everything goes back to the beginning.
Yeah. Kind of a mind-boggling concept, isn't it?
It is, but you said there are other possibilities.
Yeah, there are other contenders.
Okay.
Another scenario is called the Big Freeze,
Big freeze.
which is also sometimes called the heat death of the universe.
Oh, okay.
And in this one, the universe continues to expand forever.
Okay.
But that expansion causes everything to cool down. Eventually, stars will burn out, black holes will evaporate, and the universe reaches a state of maximum entropy.
Maximum entropy. Can you explain what that means, like in a way that my head won't explode?
Yeah, so think of it like this.
Okay.
Imagine a cup of hot coffee and a glass of ice water.
Okay, got it.
If you mix them together, the heat flows from the coffee to the ice water
Right.
until they reach the same temperature.
Okay.
And that's what we call a state of equilibrium, where everything is balanced out.
Gotcha.
So maximum entropy in the universe is kind of like that.
Okay.
It's a state where all the energy is evenly spread out and there's no more potential for anything interesting to happen.
So not a bang, not a crunch, but a slow fade to cold, dark nothingness.
Yeah, pretty much.
Okay, well, it's a bit bleak, but I guess it has a certain poetic symmetry to it.
It does.
Are there any other contenders for how the universe might end?
Yeah, there's one more that our sources talked about called the Big Rip.
The Big Rip. Oh.
And this is, it's a little more dramatic.
Okay.
It's based on the idea that dark energy, which is this mysterious force that's accelerating the expansion of the universe, might actually become stronger over time.
Okay.
And if that happens, the expansion could speed up at an ever-increasing rate, eventually ripping apart everything.
Oh, yeah.
Galaxies, stars, planets, even atoms themselves.
Oh, okay. That's definitely not a scenario I want to see play out.
It's pretty intense.
Yeah, like the universe getting shredded into its smallest components.
Yeah.
So this dark energy stuff, it sounds pretty important. What exactly is it, and why is it such a big deal?
Yeah, it's a big one. It's one of the biggest mysteries in cosmology, actually.
Really?
We know it exists because we see its effects,
Okay.
like the accelerating expansion.
Right.
But we have absolutely no idea what it's made of or where it comes from.
Huh.
Some scientists think it might be just an inherent property of space itself,
Okay.
while others think it might be a new type of fundamental force or particle that we haven't discovered yet.
So this invisible force is pushing everything apart, and we don't even know what it is.
That's where we're at, yeah.
It's like the universe has this hidden hand controlling its destiny. Are there any other big mysteries out there that are keeping cosmologists up at night?
Oh, there's plenty. There's dark matter, for instance.
Okay, dark matter.
Like dark energy, we can't see it directly,
right.
but we know it's there because of its gravitational effects on
Perfect.
galaxies and galaxy clusters and things like that. It accounts for something like 85% of all the matter in the universe.
Wow, that's a lot.
It is, but we still don't know what it's made of.
So we've got dark energy accelerating the expansion of the universe.
Yeah.
We've got dark matter holding galaxies together.
Yep.
It sounds like these two mysterious forces are engaged in some kind of cosmic tug of war.
It is, yeah.
Shaping the fate of the universe.
I like that. That's a great analogy.
Yeah.
It highlights just how much we still don't know. Even with all the progress we've made, we still don't know.
Yeah.
The deeper we go, the more we realize how many mysteries are still out there.
So where did all the stuff that makes up the universe even come from in the first place? Like, what was there before the Big Bang?
That is the ultimate question.
Right.
And it really pushes at the boundaries of our understanding.
Okay.
But some physicists believe that the universe might have emerged from what's called a quantum fluctuation.
Quantum fluctuation. Okay, that sounds incredibly complex.
It is, yeah. It's kind of difficult to explain.
Yeah.
Basically, in the realm of quantum mechanics, things get really, really weird.
Okay.
And empty space isn't actually empty. It's filled with these virtual particles that just kind of pop in and out of existence. It's almost like a cosmic foam.
Oh, wow.
Constantly bubbling with energy. And the idea is that our entire universe might have sprung from one of these particular energetic fluctuations in this foam.
So our universe, everything we know and love, came from a random spark of energy in the void.
That's the idea.
It's almost impossible to wrap my head around that.
It is, yeah.
But if our universe could arise from a quantum fluctuation, could there be other universes out there too?
That's a question a lot of people are asking.
Right.
That's the idea behind what's called the multiverse theory.
Okay.
And it says that our universe might be just one of many, maybe an infinite number of universes.
Oh, wow.
Each with different physical laws and different dimensions, even different types of matter and energy.
Okay, I think we're venturing into science fiction territory now.
Maybe not.
Yeah.
I mean, it is highly speculative.
Right.
But there are some tantalizing hints.
Oh.
Some physicists think that the cosmic microwave background radiation,
Right, the afterglow of the Big Bang.
exactly, might hold clues to the existence of other universes.
Wow.
They're looking for these very subtle patterns or anomalies in the data that could indicate like collisions or interactions with other universes.
Cosmic collisions on a multiversal scale.
Yeah, it's pretty wild stuff.
It really is. So let's say for a minute that this multiverse idea is true.
Okay.
What would those other universes be like?
Well, this is where things get really fun
Okay.
and purely speculative.
Okay.
Some theories suggest that other universes could have completely different physical laws.
Okay.
You know, maybe gravity works in reverse
Wow.
or time flows backward.
Okay.
There could be universes where the fundamental forces are different, leading to completely different types of stars and galaxies, and even life.
So there could be a universe where up is down and cats chase dogs.
That's possible.
Wow, the possibilities really are endless.
They are.
But if there are all these other universes out there, will we ever be able to interact with them? Or even just prove that they exist?
That's the real challenge, isn't it?
It is.
You see, if other universes exist, they might be totally separate from our own,
Right.
with no way to interact or even communicate with them.
Okay.
But some physicists think there might be very subtle ways to detect their presence,
Oh,
perhaps through things like gravitational waves or other exotic phenomena.
okay.
So the search is on.
Wow. It's incredible to think that we might be on the verge of discovering something as profound as a multiverse.
It's pretty amazing.
It's a reminder that our understanding of the universe is always evolving.
Always.
There's so many mind-blowing discoveries waiting to be made.
For sure.
But before we get too lost in multiverse,
Yeah.
let's bring things back down to Earth.
Back to our universe.
Our universe, we talked about its beginning and its possible endings, but what about the journey in between? What are some of the most fascinating things happening in the universe right now?
Well, one of the most exciting areas of research right now is the study of black holes.
Oh, okay.
These are regions of space-time where gravity is so strong that nothing, not even light, can escape.
Right.
And we're learning more about them all the time thanks to some incredible new telescopes and observatories.
Black holes are definitely one of the most mind-bending concepts I can think of. I always imagine them like these cosmic vacuum cleaners,
Yeah.
sucking up everything in their path.
Yeah, the common misconception.
Yeah.
But black holes don't actually suck things in.
Okay.
They have a gravitational pull,
Yeah.
just like anything else with mass.
Yeah.
But you have to get pretty close to them
Okay.
for that gravity to become inescapable.
Gotcha.
And what's fascinating is that black holes actually play a really important role in the evolution of galaxies.
Really? How so?
Well, at the center of most galaxies,
Okay.
including our own Milky Way, there's a supermassive black hole,
Oh, wow.
millions or even billions of times more massive than our sun.
That's huge.
And these supermassive black holes can really influence the formation of stars and the overall structure of galaxies. They can even launch these powerful jets of energy and matter that can stretch for millions of light years.
It's incredible to think that these invisible objects can have such a huge impact on the universe around them.
Yeah, I know.
It's a reminder that there's still so much we don't know,
Yeah,
even about things that we thought we understood.
exactly. And that's what makes cosmology so exciting. It's a constant journey of discovery.
Right.
And every new finding leads to more questions and more possibilities. And with all these new technologies and instruments coming online all the time, who knows what incredible discoveries are waiting for us in the future.
Okay, I have to ask, what are some of the big questions that cosmologists are hoping to answer in the near
Well,
future?
there's a bunch.
Yeah,
One of the biggest ones is understanding the nature of dark matter and dark energy.
right,
We know they exist, but we have no idea what they are.
right.
Solving that mystery
hmm
could really revolutionize our understanding of gravity, the evolution of the universe, and maybe even the fundamental laws of physics.
So it sounds like we're on the verge of a whole new era of cosmic discovery.
I think so.
But with all this talk of dark matter, dark energy, black holes, multiverses, it's easy to get lost in the vastness of it all.
It is.
What does all this cosmic knowledge mean for us here on Earth?
Yeah.
How does it affect our lives?
That's a great question.
Yeah.
I think on one level, it's a reminder of our place in the universe, that we're part of something so much greater than ourselves,
Right.
something that's been evolving and changing for billions of years,
Yeah.
and that our own existence is fleeting.
Wow.
Just a brief moment in the grand scheme of things.
It puts things into perspective.
It does.
All of our worries and concerns here on Earth seem almost insignificant
I think so.
when you consider the vastness and the mystery of the universe.
Yeah, but I also think it makes our lives more meaningful.
Really? How?
Well, I mean, we are stardust,
Right.
forged in the hearts of dying stars,
Yeah.
and we have this incredible opportunity to actually experience and understand this vast, awe-inspiring universe.
It's a beautiful thought.
It is.
We are literally connected to the cosmos.
We are.
But I have to admit, after all this talk about the universe's eventual demise, I'm feeling a little, well, existential.
Yeah.
Should we be worried about the end of the universe?
I mean, the good news is that even the most dramatic scenarios for the end are billions, if not trillions of years away.
Okay.
So you don't have to start prepping your doomsday bunker just yet.
That's good to know.
But I'm curious, what would it even look like to prepare for the end of the universe?
Yeah, I don't even know.
That's a fascinating question.
It is.
It really is. And I think it raises even bigger questions about the meaning of existence and the future of humanity.
Okay, you've officially sent my mind spiraling.
Yeah, it's a lot to think about.
It is, we need a moment to contemplate all this. Okay,
Mhm.
I think I've had a minute to kind of like catch my breath
Yeah,
and process all this mind-blowing information.
that's a lot.
We've covered everything from the Big Bang to the possible, well, demise of the universe. It's been quite a ride.
It really has.
It's amazing. One thing that really struck me was this idea that even as the universe is evolving and changing,
Right.
there's this incredible potential for new beginnings.
Mm,
We talked about stars dying,
yeah.
giving birth to new elements, galaxies colliding, and forming these even larger structures.
Yeah, it's pretty amazing.
It's like this constant cycle of death and rebirth, but on a cosmic scale.
That's a great way to put it. It really highlights just how interconnected everything in the universe is.
It makes you wonder,
Yeah.
if the universe is constantly evolving and creating these new opportunities, what does that mean for the future of life itself?
Mm.
Will life find a way to, I don't know, persist even as stars burn out and galaxies fade away?
Well, that's a question that astrobiologists are really trying to figure out.
Right.
And it's a tough one because, we only have one example of life that we can really study.
Right, here on Earth.
Exactly. But if we can learn more about how life began here
Hmm.
and how it's adapted to all these extreme environments,
Right.
it might give us some clues about the potential for life to exist in other parts of the universe.
So even as our own sun eventually dies, there might be other stars and planets out there, maybe even in other galaxies where life could flourish.
It's possible. Yeah, it's
Yeah.
one of the things that makes studying the universe so exciting.
Yeah.
The more we learn, the more we realize how much we don't know
Right.
and how many incredible possibilities are out there.
It's like the universe is this vast, unexplored ocean, and we're just starting to dip our toes in.
Yeah, I like that.
Who knows what we'll find?
Exactly.
This deep dive has really been a journey of cosmic proportions.
It has.
We've explored the universe's past, its present, and its possible futures. We've talked about dark matter, dark energy, multiverses, and we even touched on some pretty big philosophical questions.
We did.
It's been amazing.
It's been my pleasure. I hope it's left you with a sense of wonder and a thirst for more knowledge about this amazing universe we call home.
I definitely feel inspired to keep exploring and learning, and after all this talk about the universe's timescale, my everyday worries seem a lot smaller now.
Yeah, I think that's one of the best things about studying cosmology. It gives us a sense of perspective, reminds us that we are part of something so much bigger than ourselves,
Right.
something that's been going on for billions of years.
And who knows what incredible chapters are yet to be written in this cosmic story.
I know, the universe is full of surprises. I can't wait to see what the future holds.
Me too. Well, on that note, we'll leave you with this final thought.
Okay.
Keep looking up, keep asking questions, and never lose that sense of wonder about the universe.
Couldn't have said it better myself.
There's a whole universe out there waiting to be explored.
There is.
Who knows, maybe you'll be the one to make the next groundbreaking discovery.